Hi, hello dear students. Welcome to physics class of PU2. In the previous class discussion regarding the chapter atoms, we have discussed about the introduction part. What is an atom? What are the subatomic particles such as proton, neutron and electron, and different atomic models. The list of different atomic models we have discussed to explain the structure of an atom. In the atomic models, the first one, the J.J. Thomson's atomic model, we have discussed in detail already, and also the Rutherford's alpha particle scattering experiment due to a thin gold foil experiment we have discussed with experimental observations. What are the experimental observations? And also the conclusions we have discussed in the previous class with the definition of what is an impact parameter and the distance of closest approach. Now in this video class I am going to explain here about the Rutherford's atomic model, the Rutherford's model of an atom proposed by Rutherford in the year 1911. It is proposed by Rutherford in the year 1911 on the basis of results of alpha particle scattering experiment. Now let us discuss here the Rutherford's model of an atom. I will discuss here the first point. What are the postulates of Rutherford's model of an atom? The first one, all the positive charge and almost all mass of the atom is concentrated in a very small region at the center of the atom. This central core is called as what? The nucleus. So according to the Rutherford alpha particle scattering experiment result, what we have obtained here, all the positive charge, right, all the positive charge and almost all mass of the atom both are concentrated in a very small region at the center of the atom. So this is the first postulate. The entire positive charge and almost all mass of the atom is concentrated at the center of the atom. That central core is called as what? The nucleus. So this central core is called as what? The nucleus. So therefore sometimes it is also called as what? The nuclear model of an atom. Right, this is the first postulate. The entire mass and all the positive charge of the atom is concentrated at the center of the atom is called as what? The nucleus. Right. Now the next one, the negatively charged electrons revolve around the nucleus in circular orbits. So the charge of the nucleus is plus and the charge of the electrons is minus, negatively charged electrons. So these negatively charged electrons revolve around the nucleus in a circular orbit. So the next postulate of the Rutherford is what? The negatively charged electrons are revolving around the nucleus in a circular orbit. This is the second one. The next one, the total positive charge on the nucleus is equal to the total negative charge of the electrons outside the nucleus. So this Rutherford atomic model explains about the neutrality of the atom. That is the merit of the Rutherford's model of an atom. It explains about the neutrality, electrical neutrality of the atom. Right. So whatever the total charge of the electrons revolving around the nucleus is equal to the total positive charge on the nucleus. Right. That is the third postulate what we are going to say here. The total positive charge on the nucleus. So total charge on the nucleus is positive. That total charge is equal to the total negative charge of the electrons which are revolving around the nucleus in various orbits. Right. So this is the second one. So hence it is the third one, and hence it explains about what? The electrical neutrality. Next one, the size of the nucleus is of the order of 10 to the power minus 15 meter. Right. So the size of the nucleus is what? it is of the order of 10 to the power minus 15 meter, right? It is also called as Fermi, right? Fermi is equal to what? 10 to the power minus 15 meter. And the atom is of the order of 10 to the power minus 10 meter. The size of the atom is of the order of 10 to the power minus 10 meter. Size of the atom is of the order of 10 to the power minus 10 meter, and size of the nucleus is of the order of 10 to the power minus 15 meter. So how you can compare the size of the nucleus with the size of the atom here? For example, we have a cricket ball here. Consider this as the nucleus. So if you draw a circle with a radius of 5 kilometer, if you draw a circle of radius 5 kilometer, so this is the size of the atom and this is the size of the nucleus. So in this way, size of the atom is very large as compared to the what size of the nucleus, right? And the next one, the atom as a whole is electrically neutral. So already this one we have discussed in the third postulate. The whole atom is electrically neutral. Next one, the centripetal force required for an electron, the centripetal force required for an electron revolving around the nucleus is provided by electrostatic force of attraction. So how you all know that the centripetal force is required for a circular motion. So for the revolution of electrons around the nucleus, the centripetal force is required. That centripetal force is provided by the what? The electrostatic force of attraction between the negatively charged electrons and the positively charged nucleus. So we have the positively charged nucleus here. The electrons are revolving around the nucleus. These electrons are revolving around the nucleus, so in a circular path. So in between these two there is an electrostatic force of attraction, that is equal to what? 1 divided by 4 pi epsilon naught z e square divided by r square. So this term LHS is represents what? 1 divided by 4 pi epsilon naught z e square divided by r square. This represents the electrostatic force of attraction between the negatively charged electrons and the positively charged nucleus. So that provides the necessary centripetal force required for the electrons to revolve around the nucleus. So how we have written, you know that the centripetal force is mv square divided by r formula, but 1 divided by 4 pi epsilon naught z is square divided by r square. So how we have written this? This one is written according to the Coulomb's law of electrostatics. So according to Coulomb's law of electrostatics, the the electrostatic force of attraction or repulsion between any two charged particles is given by what? 1 divided by 4 pi epsilon naught q1 into q2 divided by r square. So according to Coulomb's law, we have written here the electrostatic force of attraction between the negatively charged electrons and positively charged nucleus. So according to Coulomb's law, 1 divided by 4 pi epsilon naught q1 into q2 divided by r square. So here q1 is nothing but what? Charge of the nucleus. So charge of the nucleus is plus Ze, and the charge of the electron is E. So the magnitude we are considering here, that is equal to what? E. So Ze into E is what? Here q1 is Ze and q2 is E. So Ze into E is what? E square. And here R is what? R is the radius of the circular orbit in which the electrons are revolving. So in this way, 1 divided by 4 pi epsilon naught Z E square divided by R square is equal to, it is the electrostatic force of attraction between the negatively charged electron and the positively charged nucleus, which is balanced by what? The centripetal force. So the necessary centripetal force required for an electron to revolve around the nucleus is provided by the electrostatic force of attraction between the negatively charged electrons and the positively charged nucleus. So likewise, what that is the gravitational force of attraction, the gravitational force of attraction provides necessary centripetal force required for planets revolve around the sun. So you can compare this model with the what? This planet and the sun and the planet system. We can compare this one. right? So Rutherford's atomic model, these are the important postulates here. The positive charge, all positive charge and almost all mass is concentrated at the center called as nucleus. Negatively charged electrons are revolving around the nucleus in circular orbits. The total positive charge on the nucleus is equal to the total negative charge of the electrons outside the nucleus. They are revolving around the circular path. So the whole atom is electrically neutral, and size of the atom is of the order of 10 to the power minus 10 meter, and size of the nucleus is of the order of 10 to the power minus 15 meter, that is Fermi, right? And the centripetal force is provided by the electrostatic force of attraction between the electron and the nucleus. So with these postulates, now let us discuss here what are the merits, the successful points given by the the Rutherford's model of an atom to explain its structure. So what is the first merit here? It explains about the electrical neutrality of the atom. So it explains about what? The electrical neutrality of the atom. The total positive charge on the nucleus is equal to the total charge on the electrons revolving around the nucleus. So it explains about the electrical neutrality, that total positive charge is equal to the total negative charge. And also it explains about the large angle of scattering of alpha particle. So you have seen in the experimental observation of alpha particle scattering experiment. So in alpha particle scattering experiment, we have seen that at some of the alpha particle, that is about 1 in 8,000, that is 1 in 8,000, that is having the large scattering angle, that is about more than 90 degree, and about 180 degree we have also, right? So with all this, what is the reason for the large angle scattering of alpha particle? That also we have explained based on the alpha particle scattering experiment. That is due to what? Then the positively charged, the entire positive charge of the nucleus, entire positive charge of the atom is concentrated at the center, that is called as nucleus. So because of the positive charge at the center of the atom, there is a large angle scattering of alpha particles. So from this model only we have discovered the nucleus here. So the Rutherford discovered the nucleus from this experiment only. So it explains about the electrical neutrality of the atom, and also it explains about the large angle scattering of alpha particles. Because of what? There is a entire positive charge of the atom is concentrated at the center of the atom, that is called as nucleus. Because of that positive, there is a large angle scattering, that is about more than 90 degree, and some alpha particles, they retraces their original path about 180 degree, right? So these are the merits of the alpha particle scattering experiment, and also about what? Rutherford atomic model, right? Now what are the demerits, right? What are the demerits of this atomic model? Let us discuss here one by one. The first demerit is what? It fails to explain the stability. So now let us see how it fails to explain the stability of the atom. According to classical electromagnetic theory, an accelerating charged particle emits the radiation in the form of electromagnetic wave, right? And any object which moves in a circle, which being accelerated constantly. So here a charged particle electron which follows a circular path, there is an acceleration. Due to that acceleration, according to classical electromagnetic theory, what happened? That revolving electron should emit the radiation, should radiate the energy continuously, right? That means what? The energy of an electron continuously decreases because of the accelerating charged particle it is now, right? According to the Bohrs atomic model, right? So due to this condition, what happens? There is a loss of energy of an electron continuously. Then what happens? Electron moves in spiral path. So then when electron starts to radiate the energy, it starts to move in a spiral path. As it follows this spiral path, finally what happens? As it follows this spiral path towards the nucleus, finally it falls into the nucleus, right? When it falls into the nucleus, then atom becomes unstable. So this is not possible because atom is a stable. So in this way it fails to explain the stability of the atom. Now the next one, it also fails to explain the origin of spectral line, right? It cannot explain the origin of line spectra of atoms. So how it is? According to the Bohr's atomic model, electron emits the energy continuously, right? Electron emits the energy continuously. Then what happens? It should use the continuous spectrum, right? It should give what? The continuous spectrum. But the atom must give a continuous spectrum. But what happens here? Some atoms gives what? A line spectra, right? According to this model, we have only about the continuous spectrum of atom we have, but also we have line spectrum also we are getting. But what is the reason for getting the line spectra of atom? That is not given the information by the what? The Rutherford atomic model. So hence it fails to explain what? The origin of a line spectra of atom, right? So in this way, these are the two demerits of what? The Rutherford atomic model, right? With the merits and demerits of Rutherford model of an atom, now let us discuss the next atomic model, that is Bohr's model of an atom. Bohr in 1913 made certain modifications in the Rutherford atomic model on the basis of Planck's quantum theory of radiation. So here Bohr combined the classical as well as the quantum concepts and gave his theory in the form of three postulates. So he given his theory, that is in the form of three postulates. Now let us discuss here what are the three important postulates of Bohr atomic model. So this is an important question for 3 marks in the examination. They will ask it for 3 marks. Write the state Bohr's postulates, or write the Bohr's postulates. Right, three postulates you have to write here for 3 marks. So first one, right? So as you know that according to the Rutherford model of an atom, the entire positive charge and the mass of the atom is concentrated at the center of the atom, that is called as the nucleus, and these electrons are revolving around the nucleus in circular orbits, right? And the necessary centripetal force is provided by the electrostatic force of attraction between the electrons and the positively charged nucleus, right? Now the first postulate is what? The electron in an atom revolve around the nucleus only in a certain permitted or the allowed orbits, which are called as what? The stationary orbits. And as long as the electron is in the stationary orbit, the atom will not radiate the energy, or electron will not radiate the energy. So according to the first postulate is, an electron in an atom revolve in a certain stable orbits, right? It revolve in a stable orbit without the emission of energy. It does not radiate any energy as long as it revolve in a stationary orbit, that is a stable orbit, right? And according to this postulate, each atom has a certain definite stable state in which it can exist. So each atom has a what? The definite stable states. It is having what? The definite stable state which has, and each possible state has definite total energy. So each orbit is having, stationary orbit is having definite amount of total energy in which the electrons are revolving. These are called as what? The stationary orbits of the atom, right? According to the first postulate, an electron in an atom revolve in a certain stable orbit or the stationary orbit. As long as the electron revolve around the stationary orbit, it does not radiate the energy, right? So and hence we can give here what? The atom is stable, right? Now the next one is what? Next postulate is what? The permitted orbits are those, right? As we have seen from the first postulate, the electron revolve in a only certain permitted or the allowed orbits, stationary orbits, without radiating the energy. So as long as the electron is revolving in a stationary orbit, it does not radiate any energy, right? And these orbits, stationary orbits, what we can define here? The energy level, right? So each energy level, each stationary orbit is having the definite amount of total energy, right? These are called as what? Also we can call it as what? The energy levels, right? Now the electrons revolve around the nucleus in a permitted orbit or the stationary orbit, in which the angular momentum of an electron is the integral multiple of h upon 2 pi, right? So what is the angular momentum of an electron, right? the angular momentum of an electron revolving around the stationary orbit is equal to n into h upon 2 pi, right? That is the second postulate what we state here, right? So the permitted orbits, right? Which orbits are permitted or allowed for the revolution of electrons around the nucleus is only the orbits, right? The angular momentum of an electron is an integral multiple of h upon 2 pi. So if m is the mass of the electron and v is the velocity of the electron and r is the radius of the electron, so you know that the angular momentum is equal to what? Angular momentum L is equal to p cross r, right? So p is linear momentum mv into r. So mvr is what? The angular momentum. So the angular momentum of the electron in which it is revolving is integral multiple of h upon 2 pi, right? Here h is a Planck's constant, right? And n is what here? Where n is called as what? The principal quantum number. So here n is what? N takes the values from 1, 2, 3 and so on, and here n is called as the principal quantum number, right? And this rule or this condition is called as what? This postulate is also called as what? The Bohrs quantization condition or Bohrs quantization rule. It is also called as Bohrs quantization rule. This is what the second postulate here, right? The electron revolve in a permitted orbits, right? The angular momentum of the electron in that orbit is what? The integral multiple of h upon 2 pi. mvr is equal to n into h upon 2 pi. This condition is called as what? The Bohrs quantization condition or Bohrs quantization rule. This is the second postulate. Now the third postulate, right? So this Bohr's third postulate has been developed or given from the what? The quantum concepts has been developed from the what? Planck and Einstein. So from it is stated here. The atom radiates the energy in the form of electromagnetic radiation only when an electron jumps from higher energy level to lower energy level, right? So you know that all the electrons are revolving in a stationary orbits, that is non-radiating orbits, and when atom radiates the energy, right? When atom radiates the energy, only when there is a transition takes place, that electron jumps from higher energy level to lower energy level. So we have the orbits here, n is equal to 1, n is equal to 2, right? N is equal to 3. In this we have various energy levels, we have various orbits we have, right? As long as the electron is revolving, for example in n is equal to 2 orbit, as long as the electron is revolving in n is equal to 2 orbit, it does not radiate the energy from the first postulate, right? And from the second postulate what we have, the electron revolve around the nucleus only in which orbit the angular momentum of electron is integral multiple of h upon 2 pi, right? And in this postulate what we are giving, the atom radiates the energy, right, in the form of electromagnetic radiation only when an electron jumps from higher energy level to lower energy level. For example, if electron jumps from n is equal to 2 to n is equal to 1, right? N is equal to 2 to n is equal to 1, it jumps, then it radiates the energy in the form of electromagnetic radiation. So in the figure I have shown here, you can refer here, when electron jumps from n is equal to 3 to 1, you can jump, it can jump, or it can take the transition from n is equal to 2 to 1, n is equal to, so higher energy level to what? Lower energy level. So only in those cases then atom radiate the energy. And according to Planck's quantum theory, the energy of the emitted photon is given by E is equal to h nu. So here energy is emitted in the form of electromagnetic radiation, right? And the energy is given by what? E is equal to h nu, where nu is the frequency of radiation, right? And the frequency of radiation is given by the expression the so here E is equal to what? H nu, that is the energy of the emitted photon, and that energy is equal to what? Difference between the energy levels in which there is a transition takes place, right? For example, there is a transition takes place from n is equal to 2 to n is equal to 1 orbit, then the emitted energy is equal to what? Difference between the energy levels, right? Now in this way what we can write here, h nu is equal to ei minus ef, where EI is what? Energy of the electron in the initial orbit, right? And EF is what? The energy of the electron in the final orbit. So in this way, what we can say here, if the electron jumps from or takes a transition from n is equal to 2 to 1, then emitted energy is equal to what? E2 minus E1. That energy is equal to what? H nu. And the frequency of radiation is given by nu is equal to what we can write here? Nu is equal to what we can write? EI minus. So EI minus EF divided by what we can write here? H. So this is the what? The frequency of emitted radiation. So third postulate is important, and this is also called as the Bohrs frequency condition, right? It is called as what? The Bohrs frequency condition. So second one is called as what? Bohrs quantization condition, and this third one is called as what? The Bohrs frequency condition. The atom radiates the energy in the form of electromagnetic radiation only when the electron jumps from higher energy level to lower energy level, and the frequency of emitted radiation is given by the what? This expression. So this postulate is given from the what? The Planck's quantum theory of radiation is used here, right? So these are the three important postulates of Bohr's atomic model. So first one says about what? Here the first one says about the orbit, that is about stationary orbit it says, and the second one it says about what? The Bohr's quantization condition, right? About the angular momentum of electron it says, in which it is revolving in orbits, it is revolving. And the third one, it explains about what? The Bohr's frequency condition. So these are the three important postulates of Bohr's atomic model. Okay, with all these discussions, Rutherford's model of an atom and its postulates, merits and demerits, Bohr's atomic model and its postulates, three important postulates we have discussed. So with all these discussions, in the next video class we will continue with the applications of Bohr's atomic model. So here Bohr's atomic model is used to apply it to the hydrogen atom, and Bohr's postulates are used to calculate the first one, the radius of an orbit. It is used to calculate the radii of the stationary orbits of hydrogen atom, and also it is used to calculate the energy of the electrons in those stationary orbits. That is the second application we are going to derive here. So first one, we are going to derive the radius of a stationary orbit expression, and the second one we are going to derive here the expression for energy of an orbit, and the third one we are going to derive here about the derivation of a wave number expression, that is the wavelength of spectral lines emitted by the hydrogen atom. So wavelength of the spectral lines emitted by the what? The hydrogen atom expression we are going to derive here. The three important expressions we have to derive here based on the Bohr's theory, right? And Bohr's theory, this is first applied to what? The hydrogen. So after that we will discuss about what is an atomic spectra. Also we have to cover here what is an atomic spectra, what is line emission spectrum, what is line absorption spectrum, and what are the hydrogen series of spectral lines. Also we have to discuss here about what? The spectral series of the hydrogen atom also we have to discuss here. So in the next video class we will discuss about these points, that is the applications of Bohr's atomic model, and also about the atomic spectra and spectral series. Okay, thank you students.